If I show you this graph and ask you to match each of the three graphs with what type of function is being shown, you would probably be able to figure this out without much difficulty. If I asked you which of these three graphs, A, B, or C, represents a linear function, you might notice that the points on graph B line up nicely along a line, and thus this is a linear function. If I asked you which graph shows an exponential function, like exponential growth or exponential decay, you might notice that in graph C, it seems as though the y values, how high up the points are getting increasingly higher as we move to the right in the graph. This represents an exponential growth function. Finally, if I asked you which represents a quadratic function, you might notice that graph A takes a parabolic shape, and parabolas are the graphs that result from quadratic functions. So if I give you a picture or a graph, it's not too hard to tell me what type of function is shown. In this section, we're going to start with a table of values, and I'm going to ask you to tell me by looking at the table of values whether it represents a linear function, an exponential function, or a quadratic function. First, let's review what we know about linear functions. When you graph a linear function, you get a line. That's why we call them linear functions. The slopes can be positive or negative or zero or undefined. And the general form of a linear function is y equals mx plus b, where m is the slope and b is the y-intercept. Notice that in this there are no exponents. There are no squared terms. X is not an exponent itself anywhere. The variable is just a plain old x in this case. If I give you a table of values, you can tell that it's a linear function by comparing how x changes, in this case x goes up by 1, with how y changes. Y goes up by 2. So when I add a constant number to x, like 1, I add a constant number to y. In this case, it's 2. You can find the equation of the line by comparing the rise and the run, in this case 2 and 1, and by finding the y-intercept, the b value, by looking in the table. Once you've identified that as x increases by 1, y increases by some constant number, you know that you're looking at a linear function. For exponential functions, the key thing to know is that the variable is the exponent in this case. They have the general form y equals a times b to the x. They may be exponential growth or exponential decay, depending on the value of a and b. If I give you a table of values, you can tell that that represents an exponential function, again by comparing how does x change, in this case x goes up by 1, with how y changes. Instead of getting a set number added to it every time, y now gets multiplied by the same number each time. In this case, y gets multiplied by 3 each time. So when I add 1 to x, if I multiply y by a constant number each time, then I'm looking at an exponential function. That number that I multiply y by each time, that's the b in the equation above. And I can find out what a is by looking at the y-intercept. Last, let's look at quadratic functions. Quadratic functions form parabolas when we graph them. They have the general form y equals ax squared plus bx plus c. The key is that in one term, the variable has been squared, ax squared. B and or c are both allowed to be 0, and it would still be a quadratic function. But if a is 0, then we would just have y equals bx plus c, and that would take the form of a linear function. How could we tell by looking at a table of values whether what's represented is a quadratic function? Well, again, we're going to start with what happens when x goes up by 1 each step. When we first take a look at what happens to the y values when x goes up by 1, there isn't a huge pattern that's apparent. To get from 8 to 2, we're going down by 6. To get from 2 to 0, we're going down by 2. To get from 0 up to 2, we're going up by 2. And to get from 2 up to 8, we're going up by 6. We call these numbers the first difference. It's sort of the first time that we take a look at the difference between each y term and the one after it. And we can sense that there's a pattern here, this positive and negative, but we don't really have a single number that goes with that pattern. What I'm going to do is repeat the same process of looking at the difference between two numbers, only instead of starting with the y values in the table, I'm going to start with the first difference numbers. So to get from -6 up to -2, I'm going up by 4. To get from -2 up to +2, I'm going up by 4. To get from +2 up to +6, I'm going up by 4. Now I see a consistent pattern there. We call this the second difference. It's like it's the second time that I look at the difference between successive terms. That word successive just means things that come one after the other. If the second difference is a constant number, then what we're looking at in the table is a quadratic function. This year, we're only going to deal with finding fairly simple quadratic functions given the values in a table. So let's say that I gave you the table above and asked you, what is a formula in the form y equals ax squared that works for the xy combinations in this table? All I really need to do is find out what does a have to be to make the tables in the value result. Well, it's a fairly simple process. I pick a point in the table where neither x nor y is 0. Because if either x or y is 0, I don't really have enough information to solve the problem. So in this case, I'm going to pick the point 1, 2. That says that for this function shown in the table, when I put in a 1 for x, I get out a 2 for y. So I have y equals ax squared, or 2 equals a times 1 squared when I plug in the point above. Now I can solve this equation for a, and I see that the formula that goes with the table above must be y equals 2x squared. This year we're not going to worry about how to find b and c for y equals ax squared plus bx plus c given a table of values. This year, you'll only need to be able to find an equation of the form y equals ax squared given a table of values. This is the end of the lesson for section 10.8.